In this video, I'll be solving the fourth part of the first problem of UPSC Civil Services Mains 2025 Statistics Optional Paper 1. So we were given x1, x2 and so on xn are random sample from normal distribution with parameters mu and sigma square. And we have to obtain the sufficient statistics for parameters mu and sigma square when the both parameters are known. And if sigma square is known, then what will be the sufficient parameter for mu? So for this, like, we can consider the joint density. So the joint density would be mu sigma square is equals to the product of this individual densities. So 1 by 2 pi sigma square into exponent of minus xi minus mu whole square by 2 sigma square. So that is nothing but 2 pi sigma square whole to the power minus n by 2 into exponent of minus 1 by 2 sigma square summation I is equals to 1 to n xi minus mu whole square. So now, like, if we expand this quadratic form inside this exponent, so that is nothing but, so this joint density f of x1 x2 so on xn with parameters mu sigma square is just 2 pi sigma square minus n by 2 exponent of minus 1 by 2 sigma square summation I is equals to 1 to n xi square minus 2 mu into summation I is equals to 1 to 10 xi plus n mu square. So that means this depends on the sample only through two functions. So this likelihood or the joint density depends on the sample only through two functions. So if we consider t1 of x as summation I is equals to 1 to n xi and t2 of x as summation I is equals to 1 to n xi square. So only these two it is dependent on. So that means by factorization theorem. So factorization theorem says L is equals to the likelihood, if we can express it in the form of g theta t of x into h of x. So then t of x would be the sufficient parameter sufficient for theta. So that means t1 of x and t2 of x here will make this will be sufficient for this mu and sigma square. So we can write the vector summation xi comma summation xi square. So this is the joint sufficient statistic for mu comma sigma square. Now equivalently we can also use x bar comma s bar for this instead of this summation xi comma summation xi square, because there is one-on-one transformation between each other. So we can also consider this, and in fact, like, these are minimal sufficient as well for this normal distribution. Now in the second case, suppose if sigma square is known, so then the joint density reduces to, so the same thing, but our g theta of f of t of x component will just comprise the 2 mu summation I is equals to 1 to n xi. So exponent of this thing into the remaining, so 2 pi sigma square minus n by 2 into exponent of minus 1 by 2. So here as well we will be having 2 sigma square, but the 2 sigma square is not dependent on this. So minus 2 sigma square and then summation xi square plus n mu square. So our parameter, like, so here, like, g theta t of x, that means this function depends only on this summation I is equals to 1 to n xi for this theta. So in case of like, if sigma square is known, so this particular joint density depends on the sample only through the summation I is equals to 1 to n xi. So basically this becomes sufficient for mu when sigma square is known. So in fact, like this x bar is complete and sufficient statistic for mu in this case. So that's what they are asking in the question. They're asking the sufficient statistic for this mu sigma square and also the sufficient statistic for parameter mu. So for the first case, the answer would be x bar and s bar, and the second case, the answer would be x bar. So that's it for this video. We'll meet in the next